friends. So myself Reshma, I welcome you to the current session on database management system. In my previous session, I have discussed about the relational model constraints. So the three main categories. So in those three categories, the second type was schema based constraints. And in this session, we will discuss about the constraints related to schema, so which are defined during data definition language. And here these schema based constraints are categorized in two cases. So first is the constraints which we can define on single relational table, and second type of constraints which are applied on multiple relational tables. The constraints which we can define on a single relational table are domain constraints, key constraints, and constraints on nulls. Then the constraints which we can define on multiple tables are entity integrity constraints and referential integrity constraints. So now we'll see these constraints one by one. So let's start with the domain constraints. So the domain constraints we have already discussed above while specifying about the domains of a relational database. So the domains are the values which we can enter to the relation, and these values must be atomic. The values which we are entering for any domain, they should be atomic. Along with that, we need to specify the data types associated with the domains. So the possible data types associated with the domains are the integers, so it may come under short int on long integer. So the next step is the real numbers. Real numbers can be represented using float and double precision float. Then if we go for special data types related to strings, so here for the string we can give the characters. The characters may be a fixed length character string or it may be variable length character string. Apart from that, we have boolean values. So what here boolean values are three logic: true, false, and unknown. So then other types of data types are date, time, and timestamp. So these are the data types which we need to follow while specifying the values. So these are the conditions or the constraints we need to maintain to enter the domain values. That is, value should be atomic, and according to the given specified data type, we need to enter the proper value. The next second type of constraints are key constraints. So to understand the key constraints, here we need to learn some very basic, most important concepts for key constraints. The first part here is the key. So what do I mean by key? Why we need key in database? So here I will take an example. For example, here is a table which contains three columns: name, department, and marks. So now with the help of one column, we'll try to, so now here whenever a table with the data is given, so now if I want to retrieve the data, then how can I retrieve the data? Which column will support me to retrieve the data? Which value to be used to retrieve the data? For example, assume that I want to retrieve name and marks if I know the value of a department. For example, here if I tell get me the name and marks for the department X. So what can I do? I will go for the department column and I will be searching for X. So here in first row also I have X, in third row also I have X. Then for which department X should I give the name and marks? It will give some confusion. Similarly, or if we take the help of value Y in the department, shall I give the name and marks by making use of the department Y? Again, it will create confusion because here I have two Y. So two departments with the name Y we have. Then which name should be given and which mark should be retrieved? So it will lead to some confusion. Or shall I take the help of marks to get the name and department? If I give 10, I have only one value I can get. For 20 also I can get, but if I want to know the name and department of marks 30, I have two tuples with marks 30. I can't get who got 30, which department got 30. So that is here, it is not possible to get the data of other columns if the values are repeated in any column. Then who will help me to get the data uniquely? So we can get the data for other columns if I have a column which contains all unique values. Now for the example, in this table, if I check the first column contains all unique values. Now if I want to get the value of B and C, is it possible to get the value of B and C by knowing value of A, C? If I want to get the value of B and C for A equal to 1, is it possible to get? Yes, I have only A one top value for A equal to 1. I can easily find B and C. If value of A is 2, then also I can get B and C. If value of A is 3, then also I can get, if value of A equal to 4, then also I can get the value of B and C, because each value of A is unique. So shall I use value of B? No. Shall I use value of C to get other values? No. So but now see here, whatever the value we have used for A as unique value to identify B, so this unique value is referred to as a key. Now if I take the combination of B and C, with the help of B and C, shall I get value of A? So check whether both the values of B and C are unique for all the tuples. SPX appears only once, QX also appear only once, Q comma X only once, S comma Y also only once. The combination of B comma C can be used to identify value of A. So now here value of A forms unique attribute, combine B and C also forming unique attribute. Then such type of attributes are referred to as key attributes. So that is, a key can be defined as a set of attributes. Key is a set of attributes which can be used to identify the tuples uniquely. Or we can also say, so because here if I take only A, then I have only one key attribute. If I take B comma C, then here I got two attributes as a key. So we can define key as a set of attributes, because we may have one attribute as a key, or more than one attribute can also behave as a key. So we can define key as a set of attributes which can uniquely identify a tuple in a relation table. Or we can also define this as a key is a set of attribute using which, or with the help of which, we can identify value of all other attributes. For example, with the help of A, I can identify the complete row, or I can identify the value of remaining attributes B and C. Then such set of attributes are referred to as key attributes. So now we'll see the type of keys. So A is a key, BC is a key, and but C is not a key. So now we'll see type of keys. The first type of key is a super key. So now if you want to say any key as a super key, it has to follow some conditions. So what are that conditions? Whenever we take two tuples, the super key is set of one or more attributes using which we can identify or select a tuple uniquely. Okay. Or we can also define super key as a combination of all possible attributes sk, a combination of all possible attributes which can uniquely identify two tuples. Here I have tuple T1 and tuple T2. So using this super key, if it is possible to identify these two tuples uniquely, then we can say such set of attributes as super keys. So now for example, here I have a relation R with four attributes A, comma, B, comma, C and D. So now we'll find the super keys. So from function A, attribute A, we are finding attribute B, C, D. So that is with the help of A, if it is possible to find all other attributes of the relation, then I can say A as a super key. So now here A can find B, C and D, so it is a super key. Similarly here have another functional dependency. So like this we have some 5 functional dependency. We'll find which are the super keys. So first one is a super key. Then with the help of AB, we can find CD. So either we are finding the complete row. Yes, all A, B, C, D are identified. So this is also super key. Now with the help of ABC, we are finding D. So means complete tuple is identified. So this is also a super key. Now with the help of BD, we are finding AC. Whether all attributes are covered? Yeah, all 4 attributes are covered, means with the help of BD, we are identifying a complete tuple. So this is a super key. Now with the help of C, we are identifying AD. Whether we are identifying the whole tuple here? No, because attribute B is missing. So we can't say C as a super key. Here C is not a super key because it is not, for C it is not possible to identify all the remaining attributes. So this is not a super key. So like this we can find the given attribute as a super key. So now for example, in a student database, here we have an example of a super key. So USN, subject code and name can be used as a super key because no two tuples have same values for all the attributes, and that can be identified with the help of this set. So this is a super key example here. So now next term is candidate key. Then what do you mean by candidate key here? So candidate key is a minimal super key. A super key is said to be a candidate key if it is minimal. Then what do you mean by minimal? So minimal is not just in terms of the count, but it has some special meaning. So now for example, here we have a set of super keys. Then to say that super key as a candidate key, it has to follow mainly two properties. The first property is two distinct tuples in any state of the relation, it cannot have identical values for all the attributes in the key. And the candidate key is a minimal super key. So means a super key from which we cannot remove any attribute, and still it has to maintain the uniqueness constraint. So means a proper subset of a super key, if it is not a super key, then we can call the super key as a candidate key. So a super key is said to be a candidate key if proper subset of the super key is not a super key. So now to understand this definition, we'll take some example. For example, here I have a set of super keys. Now from among these super keys, I need to find which are candidate keys. So now as the definition said, if a proper subset of super key is not a super key, then it is a candidate key. For example, I will start with ABC. So ABC gives this, so it is a super key. Now I need to check whether ABC can be a candidate key or not. So find the proper subset of ABC. For example, here AB is proper subset of ABC. Okay, whether AB is a super key? Yes. If proper subset of ABC is also a super key, so ABC is a super key and proper subset of ABC is also a super key, then we cannot say ABC as a candidate key. Means the minimal of ABC is AB, that is the smaller of ABC is AB. If AB can do the job of ABC, then no need to have ABC. If only AB can do whatever ABC can do, then what is the use of having three attributes? If only two attributes can do the job of AB, three attributes, then no need to have three attributes. So ABC implies D is not a minimal super key. So this is not a candidate key. So now we need to check whether AB is a candidate key. Again apply the concept of candidate key. A super key is said to be candidate key if proper subset of that super key is not a super key. So now for AB, I need to check is this a candidate key. For that, first find the proper subset. Proper subset of AB is A. Whether A is super key? Yes, A is also super key. So now again here, if A alone can do the job of AB, then there is no use of AB. So AB is not minimal. AB is not a minimal super key. We have another smaller subset, proper subset, which can behave as a super key. Then no need to use AB as a super key nor as a candidate key. So AB is not a candidate key. So then I will go for A. Whether proper subset of A can be a super key. So here I have only one attribute A. I can't find the proper subset of A. So A itself is the minimal. A itself is the smallest. So this smallest super key, minimal super key is referred to as here candidate key. So A implies BCD is a candidate key. So now we'll go for BD implies AC. Whether BD is a super key? Yes, BD is a super key because with the help of BD, I can identify that particular tuple. So BD is a super key. So now we need to check whether BD is a candidate key. To check whether BD is a candidate key, I need to find proper subset of BD. Proper subset of BD means either B or D. Whether B is a super key here? No. Whether only D is super key? No. So neither B is a super key nor D is a super key. Means the proper subset of BD is not a super key. If proper subset of a super key is not a super key, then that super key is a candidate key. So that is proper subset of BD is not a super key. So BD itself is the smallest set which is behaving as a super key. The proper subset of BD is not a super key. So BD remains a candidate key. Now whether C implies AD is a candidate key. For that first we need to check whether C is super key. C is not a super key, then there is no question of a candidate key. So like this we can find the candidate key from a given super key. And if we go for any relation schema, we can have more than one candidate key, and each of the key will be referred to as a candidate key. If I go for car relation, we have two candidate keys, license number and engine serial number. So next is the primary key. So now as we know, a relation can have more than one candidate key. Among those candidate keys, one of the key should be selected as the primary key. Is there any condition to select any attribute candidate key as a primary key? No. So the decision will be taken by the database administrator. The DB has to decide which candidate key can be considered as a primary key, but internally, semantically, they can make use of some condition for the selection of a primary key. If I go for student, so there I will use USN as a primary key. Then next, unique key. Again, a relation schema, it may also have more than one key. The one of the key will be considered as primary key. The remaining keys will be considered as the secondary keys or the unique keys. Then the null constraint. So this null constraints we have discussed many times before. Just here I will highlight whenever we are entering the values for the attributes in a relation. For some of the attributes we may enter no value. So means we can leave the value of some of the attribute as empty, null. So in which condition? What are the conditions where it will accept the null value? So here I will just note some of the situations where you can leave it as null. For example, if you are a student and you want to enter your salary, whether salary field is applicable to the student? No, so this is not applicable to the student, so I can leave null. Assume that you left the job, then in that case your salary column should be null. Again, if you don't have office phone number, in that case we need to fill null. You want to enter birth date of your college administrator, or you want to enter birth date of your grandfather. Can you enter the birth date? The birth date is available, but you are not remembering currently. The value is unknown or missing for the current situation. Then we can leave null. Assume that you are staying in independent home, but it is asked you to enter the apartment number. Can you enter the apartment number when you're staying in independent home? No, it is not applicable. So there are some situations where it is not possible to enter the value, like if the value is missing, if the value is not defined, if the value is not applicable. In such cases, we can leave it null. So then next type of constraint is the constraint which we can use for multi-table tables. So that is entity integrity constraint. Entity integrity constraint states that no primary key value can be null. Once we have selected one of the attribute of a relation as a primary key, at no situation we can leave the value empty. No primary key value can be null. You cannot give the condition as I have not remembered. For example, if you have taken USN as primary key for student, you can't leave USN as null by giving the reason as I forgot the USN. USN is not applicable for this. USN is missing. USN is not defined. No, you cannot give any reason and can't leave the value of USN as null. So that is referred to as here entity integrity constraint. That is no primary key value can be null. So here I have given USN as null, but this is not acceptable because this will violate entity integrity constraints. So next is referential integrity constraints. So in referential integrity constraint, so state that as this is specified between two or more relations, so this is used to maintain consistency among tuples in the two relations where this referential integrity constraint is used. So this states that again a tuple in one relation that refers to another relation, it must refer an existing tuple in that particular relation. So for example, here a set of attributes foreign key in a relation R1, it behaves as foreign key of R1 that refers to R2 if it satisfies some condition. First condition, the attributes in foreign key have same domain as primary key in R2. Then attributes Fk are said to refer to the relation R2. So here the domain for primary key and foreign key should be same. The next condition, a value of foreign key in tuple 1 which either occurs as value of primary key or it can be null. That is, foreign key value must be same as primary key. If it is not same as primary key, then we can leave it as null. So for example, here I have an employee table where SSN is the primary key and project table where ESSN is the foreign key. Then what value we can go for ESSN, the foreign key in project table? The value should be same as SSN. So here I have used 1002. Okay, it is available in employee table SSN. Then I have used 1001. It is also available. Here 1002 appears twice in the foreign key. Yes, foreign key value can be repeated. And for the first row, I have null. Yes, foreign key value can be null also. So foreign key value can be null. It should be same as primary key value, and the value may be repeated. So this is about the foreign key constraints. So in this session, we have discussed very important concepts like super key, candidate key, entity integrity constraints, and referential integrity constraints. So these are very important concepts, and go through these videos about these concepts. If you have any doubts, please send your questions to the comment section. And in my next session, I'm going to discuss once again the key concept, super key and candidate key, with the questions related to gate or placement or any interview questions. We'll try to solve some examples related to super key and candidate key. Thank you.